you by thesis123.com. I learn and teach online.
Here's the next question, number 9. Two semi-infinite dielectric regions are separated by a plane boundary at y is equal to 0. The dielectric constants of region 1, where y is less than 0, and region 2, where y is greater than 0, are 2 and 5 respectively. Region 1 has uniform electric field, which is given as E bar is equal to 3ax cap plus 4ay cap plus 2az cap, where ax, ay and az are unit vectors along x, y and z axis respectively. The electric field in region 2 is, well, we have our 4 options given. Now, we have been given 2 regions, region 1, region 2. Here y is less than 0, y greater than 0. Epsilon 1 is given as 2, epsilon 2 is given as 5. Now we also have our electric field equation as 3ax plus 4ay plus 2az. Now in order to find out the electric field in region 2, we will have to note 2 very important facts. Now this is with respect to wave propagation. According to wave propagation, we have 2 certain components. One, those that are parallel and those that are perpendicular. So, according to wave propagation, let's look at the first point. Now, the first point deals with the parallel components. The parallel components of the dielectric medium will be the same for both. So the parallel components of both regions R1 and R2, region 1 and region 2 will be the same. So you will have to note that the parallel components correspond to AX and AZ, okay? So in this case, the components AX cap and AZ cap, these 2 unit vectors will remain the same for E1 and E2. Now you might ask why AX and AZ are supposed to be the parallel components. Now this is answered in the question here, that says that the 2 semi-infinite dielectric regions are bounded by the plane y is equal to 0. The plane y is equal to 0 forms the boundary line between the 2 regions, and because of that the y component, that is AY, is the perpendicular component. The other unit vectors AX and AZ will be the parallel components. I hope that's clear. Now the second point is the perpendicular component. The perpendicular component of the dielectric medium will be equal. The ratio will be equal, which means that epsilon 1 E1 is equal to epsilon 2 E2. This is only for the perpendicular components. Okay. So now let's analyze each point. Now the first point talks about the parallel components. The parallel components are AX and AZ. Now if we look at the equation here, I'll write the equation down again. E1 is 3AX plus 4AY plus 2AZ. Now AX and AZ are the parallel components. So for E2 they would remain the same. 3AX cap, 2AZ cap. So the component that will change now is the perpendicular component, 4AY. Now the ratio is epsilon 1 E1 equals to epsilon 2 E2. Now using this ratio, let's find out what is the perpendicular component of E2. So this means, this implies, what is epsilon 1? Epsilon 1 is 2. 2 into the perpendicular component of E1 is 4AY is equal to 5 into E2. Now we need to find out what is E2. The component of E2, the perpendicular component of E2. This would be 8AY cap divided by 5. So it's just solving this equation here. So 8 by 5 gives us 1.6. So this particular element here is 1.6 AY cap. So here is our electric field for region 2. 3AX cap plus 1.6 AY cap plus 2 AZ cap. This is our final answer. So it matches option A. Well, this is the explanation and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.